Okay, on to question two. So, question two is about the required practical, which is the thermal insulation required practical. So, a student investigated the properties of three types of insulation. And this picture shows what's going on. So it's always good to have a look at these pictures and try and figure out what's happening here. So we've got a temperature probe in the metal plate, and then we've got a temperature probe in the insulating material. So the energy is going to be going from here through to here. So that's what's happening. And the insulator is going to try and reduce that energy transfer from the hot metal plate to this temperature probe. So that is our energy. So in the investigation, different insulating materials were placed in contact with the hot metal plate. The temperature probes measured the temperature on each side. The temperature probes were connected to a data logger. Figure 2 shows how the temperature measured by the temperature probe 2, so this is going to be this one, the one on the opposite side than the hot metal plate, how it changed over 10 minutes for each of the materials. What was the temperature of the hot metal plate? So the hot metal plate, let's say, was on this side, and the energy is going to be transferred through. So if we had no insulation on there whatsoever, then temperature probe 2 would tell us the exact temperature of the metal plate. So we have to imagine we've got no insulation on there, or one of them is a very poor insulator. And then we can see that our highest temperature was here for material A. So if we draw that line across, we can see that that line, I'm not doing very well, but lines up with 80 degrees. So the temperature of the hot metal plate is going to be 80 degrees. And we can already see that material A is going to be our least effective insulator. It allowed all of the energy eventually to go through. It only slowed down the rate of energy transfer a little bit. So our next question says, which material is the best insulator? So we can just go back. So the best insulator is the one that's going to have reduced the rate of energy transfer the most. And we can see that that's material C. Material C is the best because the final temperature after 10 minutes is lower. So material, just check it. Don't want to get that wrong. Yeah, good. Material C. And it's because the final temperature is the lowest of all three materials. Right, let's look at part C. Another student replaced the investigation but doubled the thickness for all three. Suggest how using a thicker insulation would affect the results of the second student's investigation compared with the first. Well, if we've got thicker insulation, then we would expect the temperature increase to be slower because the energy transfer would be less, because the whole point of insulation is it slows down energy transfer. So we could say that the temperature rise for all materials, that is a terrible, there we go, would be lower. The temperature rise for all materials would be lower, and that will be, because we have 2 marks, so that's a statement. A second, so we're going to have a reason why. Because the rate of energy transfer would be lower. So the temperature rise for all materials would be lower because the rate of energy transfer would be lower. And just read the question back. Suggest how using thicker insulation would affect the results. Yep, that answers that. So good. And I think I would, I'd get a mark here for saying that it would be lower, and the second mark for saying because the rate of energy transfer is lower. D. The students could have used the thermometer instead of temperature probes. and a data logger. Figure 3 shows the data logger screen and a thermometer. Give 2. All right, let's get the highlighter out. I know it's an easy thing, but it's very easy to miss that. And we just want advantages. So 2 advantages. So no disadvantages. I'm not talking about anything that's wrong with it. 2 advantages of using the data logger. Well, the first thing you can see that the data logger has got a decimal place, whereas our thermometer has not. So the resolution of the data logger is 0.1 degrees Celsius, whereas our resolution of the thermometer is 1 degree Celsius. So the data logger is higher resolution. And because it's higher resolution, that's going to mean that it's much easier to read, and there's going to be less chance of misreading it. So reduced chance of misreading the temperature. Okay, 2 points, absolutely. Last one. So the table gives information about 4 types of insulation that could be used for insulating the cavities of houses. And so what we're going to do is, generally when you get a table, pick out your highest and your lowest. So here's going to be our highest, and here is going to be our lowest. This is insulation. So thermal conductivity. So the higher the number, so higher is it means that there's more conduction. So more conduction, so worse insulator. So this one here is the worst insulator, the felt wool, and the foam here is going to be the best. The best insulator because it's the worst conductor. So we have got to explain which of the types of insulation in the table would be the best to use for cavity wall insulation. So we have 2 marks. So it's 1 mark for stating which it is, and the second mark for saying why. So we want it. The whole point of cavity wall insulation is to reduce energy transfer in the home. So we want to use the best insulator. So we would use the polyurethane foam because it is the worst conductor, so the rate of energy transfer would be the lowest. Yeah, so therefore we would have less heat traveling through our walls. 2 marks. I've stated which one, and I've said why. So yeah, good. That's question 2 done. All right, join me back for question 3.